All right, so today we're going to start in on looking at exponential functions, and today we're going to start in topic 1, looking at geometric sequences. So you see our goals for today, we want to recognize that sequences are functions, sometimes defined recursively, so we're going to be looking at what a recursive sequence is, and we're going to construct exponential functions, which are the same thing as geometric sequences, and using that as a table and a graph. All right, so let's start with an introduction here. We've got a series of numbers, and if you look at these numbers, 3, 6, 12, 24, what is the pattern that we can figure based on these numbers? All right, so we've looked at arithmetic sequences before, which is where we added and subtracted numbers to get to the next one. So if we took 3, we could do 3 plus 3 and get 6, right? We could also then, that means the pattern would have to hold. We have to do 6 plus 3. Would that get us 12? Well, in this case, that wouldn't work. We're not adding 3 as we move throughout this, through this series of numbers. So what else could we do to figure out what's going on here? Well, another thing, to get from 3 to 6, we could be multiplying by 2. 3 times 2 makes 6. Does that pattern work throughout this whole thing? 6 times 2 would also be 12. 12 times 2 is 24. So the pattern from 3 to 6 to 12 to 24 is that we multiply by 2 every time. We take the number and we multiply by 2. This is what's called a geometric sequence. Each term in the sequence is the product of the previous term and some real number. In this case, that real number is 2. We're multiplying each term by 2 to get the next term in the sequence. All right, so we can show this in a table. So we look here that we've got the term number, what we call that term number. So the first term in the sequence, we're calling that A1. All right, and the first term in that sequence, A1, is 3. So to get to the second term, we call that one A2. How did we get from A1 to A2? We multiplied by 2 because we did 3 times 2 and we got 6. All right. Then to get the third term, A3, we took the second term, A2, and we multiplied by 2. So we did 6 times 2. And we followed that pattern. 12 times 2 made 24. So if we were to keep going, we stopped at the fourth term, A4. If we were to keep going, the fifth term would be A4 times 2. So 24 times 2 would be 48. So if we wanted to find any term in that sequence, right, if we wanted to find what we call the nth term of the sequence, or AN, we would take the number before it. So what is the number before AN? Well, think of it this way. What's the number before A3 or A4? It's 4 minus 1, right? A3. So if we're looking for any number in the sequence, the one before it we would call AN minus 1. And in this particular case, we're taking that term, the number before the one we're looking for, and we're multiplying by 2. What does that look like in function notation? So in function notation, we don't use A's or numbers like this. We call it F. F of X. Remember, function notation means F of X. So if X is 1, if we're looking for the first term, F1 is a formula to find the first term. So what would be a formula to find the second term? Well, that would be F2. F3 would be a formula to find the third term. F4, a formula to find the fourth term. What would be a formula to find the fifth term? F5. So for any number in the sequence, if we're looking not for a specific number, 1, 2, 3, 4, 5, what if we're looking for F of n? Well, that's a formula to find what we would call the nth term in the sequence, and that n stands for any number in the sequence. Okay, so n could be any number. So it could be the 12th term, it could be the 100th term, it doesn't matter. N is any number that we're looking for in a particular sequence. So how can we take what we know here based on what we have to figure out the 10th term in the sequence? We can use first what's called a recursive process. And the recursive process uses the previous term in the sequence that we're looking for. So if we're looking for the 10th term, we need to know what the 9th term is, because we're taking the term before it, the one right before 10 is 9, so we're taking the 9th term and we're doing something to it. We might be, in this case, we're multiplying by 2, remember? So we need to figure out what the 9th term is in order to figure out the 10th term. And so let's take a look at this table. Here we've got the term numbers 1 through 10. What we call those, the first term we call A1, the second term we call A2, and so on, 3, 4, 5. How are we getting those numbers? So we're starting with 3, and to get the next number, we multiply 3 times 2. Then to get the third number, I take that, 6, and I take 6 and I multiply by 2 to get 12. Then I do 12 times 2 to get 24. 24 times 2 is 48. 48 times 2 is 96. 96 times 2 is 192. Then I take that, 192 times 2 to get 384. So what would the next term be? Well, I would need to take what I had before, 384, and multiply it by 2, and that gives me 768. So the 9th term in the sequence is 768. So remember what we said, we're looking for the 10th term in the sequence. Well, I need to know the one before it, which is 9. So now I know that the 9th term is 768. So I take 768 and multiply by 2. That'll give me 1,536. So the 10th term in the sequence is 1,536. How did we get that? Well, we took the number before it, the 9th term, and we multiplied by 2. So what is a formula that we could come up with if we wanted to find any number in the sequence? Well, if I'm looking for any number, I need to know the one right before it, right? If I wanted, since in order to get the 7th term, let's say, A7, we took A6 and we multiplied by 2. Right? If we were looking for the 3rd term, A3, we took A2 and we multiplied by 2. Notice the relationship here between these numbers. We're always taking the one right before it. So if we're looking for AN, the one right before that we would call AN minus 1. Right? If we're looking for 10, we need the 9th term. If we're looking for 7, we need the 6th term, or 3, we need the 2nd term. So we always take the one right before it, which is N minus 1. And in this case, we're going to multiply that term before it by 2. So here's my recursive formula for this particular situation. To find any number, we need to take the previous term and multiply it by our ratio or our common factor. What if we want to use what's called an explicit process? The explicit process is different. The explicit process uses the first term and relates everything back to the first term. And the first term we call A1. That's the first term. So everything is going to get related back to that first term. So we're still looking for the 10th term in the sequence, but we're relating it back to the first term. And what are we doing with that first term to get to each subsequent term in the sequence? So if my first term is 3, how do I get the second term? Well, same pattern, right? I do 3 times 2. But now what if I want to get to the third term? I don't want to use necessarily the second term. I still want to use 3. But how did I get from 3 here? Well, I did 3 times 2 and then times 2 again, right? So 3 times 2 times 2, which is what you see here, 3 times 2 times 2. We could rewrite 3 times 2 times 2 as 3 times 2 squared. Right? 2 times 2 is 2 to the second power. Or if we want to find the fourth term, well, I just take what I had before, 3 times 2 times 2, and I multiply it by another 2. So that 2 squared becomes 2 times 2 times 2, which is 2 to the third. So each time, I'm just adding another 2 that I'm multiplying. So for the seventh term, I take the 6 that I multiplied before and add another 2. For the eighth term, I take the 6 that I had before and multiply it by another 2. So I've got 2 to the seventh power. What if I want to find the ninth term? It's still going to be, so it's going to be 3 times 2 to the seventh power multiplied by another 2, which is going to be 3 times 2 to the eighth power. What is that? That's still 768. What if I want the 10th term? Take the one before it, 3 times 2 to the 8th, and multiply it by 2 again. So it's 3 times 2 to the 9th, which is 1,536. Okay? So we're always taking A1 no matter what. Right? What's changing is how many 2's I'm multiplying by. Right? And if you notice, the number of 2's that I'm multiplying by, if I'm looking for A10, I multiplied 2 9 times. If I was looking for 9, I multiplied 8 times. 8 was 7, 7 was 6, 6 was 5, and so on. So notice the number of times that I'm multiplying by 2 is 1 less than the number that I'm looking for. And then I'm always taking that number of 2's times the first term. And in this case, I know what the first term is. So for this particular one, any number in the sequence is the first term, which is 3. Right? A1 is 3. And it's multiplied by 2, 1 less times than the number that I'm looking for. So if I'm looking for the 10th term, I'm taking 3 and multiplying it by 2, 1 less time than 10, or 2 to the 9th power. So this is my explicit formula here. AN is 3 times 2 to the n minus 1 power, based on the first term in the sequence, rather than the previous term. AN is still any number, but now I'm using the first term, and I'm multiplying it by 2, which is still that ratio that we had, right? Or the common factor. But now I'm multiplying that number 1 less than the number of times I'm looking for in my formula. All right, so what will that graph look like? So let's take this this situation that we've got. So we've got here the first 6 terms of our pattern, 1 through 6. So that's going to be our x value. So our term number is our x value. So we're going to do 1, 2, 3, 4, 5, and 6. And we could go 7, but we don't have 7. All right, so notice I'm just spacing them out so I have enough room for the entire thing. So that for the y-axis here, so that's x and y. For the y-axis, that's going to be the term. What is the number that we're measuring? So for this one, let's count by 5s. So all these little marks here. But instead of writing 5, 10, 15, I'm going to jump by 10s, but just understand that I'm skipping the 5. So if we started with 5, then 10, 15, 20, 25, 30. Here I'm going to start skipping and jumping up to 10. So 40, 50, 60, 70, 80, 85, oops, sorry, that should be 90, and then 95 at the very top here. All right, so now we just need to put this information on the graph. So what is the first term in the sequence? Well, the first term is 3. So 3 on the graph is going to be less than 5. So 3 is about there. The second term is 6, or we took 3 and we multiplied by 2. So the second term is 6, so I'm going to put it just above 5 on the graph. The third term is 12, so for 3 is going to be at 12, so there's 10, a little bit above, not quite halfway for 12. 4 is at 24, so 4 is up at 24, so a little bit less than 25. 5 is 48, so the fifth term is up at 48, so I got to go up almost to 50. And 6 goes all the way up to 96, so that's 95 was the last line here, so it's right above 95. So what do you notice about this graph? One, it's not linear. Okay, it's not a straight line. We've looked at graphs mostly with straight lines. This one is a curve. Right, if we were to connect these points, we would see that it creates kind of this curve as they go up on the graph. The other thing you should notice is that once it reaches this point here, once it's doubling, it increases very quickly. So it increases very quickly. So geometric sequences, which is what this is, geometric sequence, once it's doubling or tripling or whatever the factor is, it starts spacing out a lot more as you move further along. Okay, so the main things to take away from this one is that a recursive process uses the previous term in a sequence. So if they ask you for a recursive formula, you're using the previous term in the sequence. An explicit process uses the first term in the series. Okay, so the explicit process refers back to the beginning, back to the very first term in the sequence. So that's the difference between the two types of formulas that you can create. All right, so let's look at a couple of examples here. Consider this sequence, -2, 4, -8, and 16. We're going to write a recursive formula. So remember, recursive uses the previous term in the sequence. So we need to know what is happening to the term before it that is changing. So if the first term, A1, A2, A3, and A4, how are we getting from each term to the next term? How are we getting from -2 to +4? -2 times what makes +4? Well, here I'm multiplying by -2. Does that pattern work? 4 times -2 makes -8. That's correct. -8 times -2 is +16. So what am I using for my recursive formula? So for any number in the sequence, I need to take the one before it, or n-1, and multiply by that common factor, -2. And so that's my recursive formula for this pattern. I take the number and multiply by -2 to get the next number. Okay. What about an explicit formula? An explicit formula goes back to the first term. So if I'm looking for any number in the formula, I need to include the first term. And if you look here, we're taking the first term, -2, and for each one, we're multiplying by -2. So -2 times -2 one time would be positive 4. What if I wanted to jump not from the first term to the second, but from the first to the third? Well, then I'm doing -2 times -2. So I'm doing it 2 times. What if I wanted to jump from the first to the fourth term? I'm doing -2 3 times. Right? So we're multiplying the first term times, that's still common factor, -2, but always one less time than the number that I'm looking for. Okay. And for this one, since I know what the first term is, let me just go ahead and write the formula using the first term. In this case, it's -2. And I'm multiplying that first term times -2, n minus 1 times, right, based on what number I'm looking for. So now let's use this explicit formula to find the 12th term in my sequence. So we're doing A1 times -2 n minus 1 times. So if we're looking for the 12th term, we know the first term is -2. Okay. Then we're going to multiply -2 by -2 one less times than the number that I'm looking for. Since I'm looking for the 12th number, I'm going to be multiplying -2 11 times. So -2 times -2 to the 11th power. And if you have your calculator, go ahead and double check on this. -2 to the 11th power would be -2048. Okay. And if I do -2 to the 11th power and then multiply that by -2, because that's my first term, that's A1, doing A1 times however many times I need to multiply -2 will give me a positive 4,096. All right, so if we were to extend this formula here, -2, 4, -8, 16, all the way out to 12 terms, we would be up at positive 4,096. All right, so now's your chance to try it. You're given the first 4 terms of a sequence, so you've got 7, 14, 28, 56. You're going to write first a recursive formula, so remember that uses the previous term in the sequence. And then you're going to write the explicit formula, which uses the first term. And then use the explicit formula to find the 20th term in the sequence. So go ahead and pause the video and solve that on your own, and then come back to check your work. All right, so looking at these numbers here, 7, 14, 28, and 56, the first term is 7, the second term is 14, the third term is 28, and the fourth term is 56. How are we getting from one term to the next? Well, 7 times 2 is 14. 14 times 2 is 28. 28 times 2 is 56. So our pattern is we're taking the previous term. So if we're looking for any number in the sequence, we're taking the one before it, which is n minus 1, and multiplying by 2. So my recursive formula is to find any number, I need to know the previous number and multiply by 2. Well, what if I want to write, part B, an explicit formula? Well, to find any number there, I need to know the first term, which is 7. A1 is 7. And if I want to know what A2 is, I'm doing 7 times 2. If I want to know A3, I'm doing 7 times 2, and then times 2 again, which we know is 7 times 2 squared. If I want to know the fourth term, I'm doing 7 times 2 times 2, and then times 2 again. So that's 7 times 2 to the third power. So using the explicit formula, I'm taking that first term and I'm multiplying it by 2 to 1 less than the number that I'm looking for. If I was looking for the fourth term, I multiplied 2 3 times. If I was looking for the third term, it was 2 twice. The second term was 2 to the first power. So the explicit formula for this particular one is for any number in the sequence, I take my first term, 7, times 2n minus 1 times. Right? So that is my explicit formula for this sequence. So if I want to know the 20th term, A20, I need to take 7, and then I would multiply 20 minus 1 times, which would be 7 times 2 to the 19th power. So again, if you've got your calculator, you'll see that this number gets pretty large. 2 to the 19th power would be 524,288. And if I take that and I multiply it by 7, the 20th term in this sequence would be 3,670,016. 16. Right? So if you were to follow this pattern, 7, 14, 28, 56, all the way down to the 20th term, do that 1, 2, 3, 4, another 16 times, you would end up at 3,670,016. Okay, so see if you can take this word problem here. An art gallery was showcasing a 6-inch long photo of a geometric landscape, and the picture was enlarged 10 times, each time by 125% of the previous picture. Enter the formulas that will give the length for each print. So you're going to find the first term, A1. You're going to write a recursive formula, which again, remember, uses the previous term. And then you're going to write an explicit formula, which uses the first term. And so go ahead and pause the video and then come back and check once you're ready to move on. All right, so we know, what do we know? We know the first term in this sequence, the original picture was 6. So A1 is 6 in this case, right? We started with a 6-inch long photo. And then the picture was enlarged by 125% to get to the next one. So the next one took that first picture and increased it by 125%. So to figure this one, you need to know that 125% is what? How can we, because we can't use a percent in computation. We've got to change this either to a fraction or to a decimal. So if I've got 125, my decimal point is out here at the end, right? It's there. So 125% as a decimal moves this decimal point 2 places to the left. So 1, 2. So 125% as a decimal, remember, would be 1.25. So to get my second picture, I would take that original picture 6 and multiply it by 1.25. What if I wanted the third term? Well, I would take 6 times 1.25 and then multiply that by 1.25 again. The fourth term, same idea. Take 6 times 1.25 times 1.25 and multiply it by another factor of 1.25. So what is our recursive formula? Well, we're using, remember, the previous term. So if I'm looking for an, I'm going to use an minus 1. And what am I going to multiply that previous term by? In this case, I'm multiplying it by 1.25. So whatever the number was before, I multiply by 1.25 in a recursive formula. In the explicit formula, we're using the first term. And we multiply by 1.25 how many times? Well, if we were looking for 4, the fourth term, I multiplied by 1.25 to the third power. If I was looking for the second term, we multiplied it to the second power for the third term. So it's always 1 less than what the number that we're looking for. And in this case, instead of saying A1, I can say it's 6 times 1.25 n minus 1 times. So the explicit formula would be the first term, 6 times the factor 1.25, 1 less than the number that I'm looking for.